Good morning, everybody. Hi, we are here. Sorry, we're a few minutes late starting the session today. We have lots of sessions going on, so we're just starting a little bit later. But thank you so much to all of you guys for sticking around and for joining us this morning. I hope you had a really good bank holiday weekend. Today's session is a GCSE Maths session, but it's foundation level, which is fantastic because we had lots and lots of you requesting for foundation level. So today we have a session which is our first foundation session that's going to be led by a new tutor for maths, because we usually have a different one. This is a specific tutor for maths foundation on the My Tutor online school called Evelyn, and she has done lots and lots of tutorials with My Tutor, and she's also studying for a master's degree in mathematics at the University of Birmingham. So I am just going to say that as usual, all of these sessions are recorded, and Evelyn will be tutoring for about an hour or so, and she'll be taking questions as well. So if you have any questions, then send them through to the chat or to the Q&A. I'm just going to hand over now to Evelyn, who is going to exit these slides and head back into the session for you. Great, thanks everybody.
Okay, hi guys. So we're going to be doing some work on factors and multiples today. So let me just get that up as well here. So we're going to be looking at finding multiples and factors. So particularly, we're going to be looking at what are multiples, what are factors, what are prime numbers, how to write the numbers as products of their prime factors, and how to find the highest common factor and the lowest common multiples. So let's get started. So first of all, what is a factor? So a factor is a number that divides into another number exactly without leaving a remainder. So for example, what are all the factors of 24? So for this one, what we should do is we should start from 1 and think of, can every one of these numbers be factors of 24? So 1 is a factor of 24 because we can do 1 times 24, which equals 24. So we know that 1 and 24 are factors of 24. Is 2 a factor of 24? It is, because we can do 2 times 12, which will give us 24, and then so on. So is 3 a factor? It is, because we can do 3 times 8. And is 4 a factor? It is, because we can do 4 times 6. And there are no more factors than the ones that we've already written down, because if you think about 5 isn't a factor of 24, and the next one after that would be 6, and we've already written 6 down over here. So we've got all the factors here, so it would be 1, 2, 3, 4, 6, 8, 12, and 24. Okay, so we can do exactly the same thing for 100. So can we go into 100? It can, because we've got 1 times 100, which gives us 100. 2 times 50 gives us 100. 3 isn't a factor of 100, but 4 is, because you can do 4 times 25. And 5 is also a factor of 100, because you can do 5 times 20. 6, 7, 8, and 9 are not factors of 100, but the last one that we do have is 10, because you can have 10 times 10. So all our factors of 100 would be 1, 2, 4, 5, 10, 20, 25, 50, and 100. So one thing to remember is that 1 and the number itself are always factors of the number. So let's say when we looked at 24, 1 and 24 are factors, and when we looked at 100, 1 and 100 are factors. This is always the case with all numbers. So let's look at the next slide. So we've got, what is a multiple? So multiples of a number are the numbers that belong to that number's times tables. So we can have an infinite number of multiples. So let's say for 3, what are the first 5 multiples of 3? So 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. And 3 times 5 is 15. Those are the first 5 multiples of 3. If we continued, we get to 18, 21, 24, and just keep adding 3. Yeah? So if we wanted to think about the first 5 multiples of 11, the first one would be 11 times 1, which is 11, then times 2, which is 22, and then it would be 33, 44, and 55. So that's what a multiple is. And again, for all numbers, the number itself is also a multiple. So 3 is a multiple of 3, and 11 is a multiple of 11. So that leaves us on to prime numbers. So a prime number is a number that has exactly 2 factors, so 1 in itself. Now, because a prime number has to have exactly 2 factors, 1 is not a prime number because it only has 1 factor, which is 1. So 1 is never a prime number, but 2 is our smallest prime number. So 2 is a prime number, yes, because 1 times 2 equals 2. So 2 has 2 factors, 1 and 2. So 1 and itself. Now 9 is not a prime number because even though you can have 1 times 9 is 9, you can also have 3 times 3. So it doesn't only have 2 factors, it has 3 factors, 1, 3, and 9. So if we wanted to think about the first 10 prime numbers, our first one is always 2, then it's 3, 5, 7, 11, 13, 17, 19, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 23, and 29 is our last one. These are the first 10 prime numbers. When we check all of them, we realize that they all have only 2 factors each. Yep. So let's go on to the next one. Oops. So powers. So one particular thing we need to remember when we are doing highest common factors and lowest common multiple questions is how to write numbers with their powers as well. So a power is also known as an index number, and an index number or power tells you how many times the number should be multiplied. So if we look at the first one, 3 squared, that's the same as saying 3 times 3. So we're timesing 3 by itself twice. So 3 times 3. Now 3 times 3 is just 9. Yeah. So that means that 9 is a squared number because we did 3 squared. Now, for 4 cubed, so the power of 3, this would just be 4 times 4 times 4. So we're timesing 4 3 times. Then 4 times 4 times 4 gives us 64 because we've got 4 times 4 is 16, 16 times 4 is 64. Yeah. So then we have the next one is 2 to the power of 5. So that means that we times 2 5 times. So 2 times 2 times 2 times 2 times 2 is 32. Because we've got 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32. So this will become more apparent when we go through to the next 2 questions, why we needed to know that. So prime factors. So we already know what a prime number is. It only has exactly 2 factors, 1 in itself. Now prime factors are factors of numbers that are themselves prime numbers. So in your GCSE, you're supposed to be able to write numbers as products of their prime factors. So the way how we do this is we use something called a prime factor tree. So we start with the number and we think of different numbers which are factors of this number, and then we start to draw a tree. So the easiest way to start these sort of questions is to think, is the number an even number? If it is an even number, then we know that it has a factor of 2, because all even numbers have factors of 2. So for this question, we have 32. Now 32 is an even number, so we know that 2 is a factor. Now 2 times 16 gives us 32. Now when we realise that we have a prime number, we need to circle it. So we circle the number 2. Now once we've circled the number, there's nothing else that we can do about it. It's already a prime number, we can't split it anymore. So we go to the next number, which isn't a prime number. So 16 is not a prime number. We can split it even further. Now 16 is an even number, so we know that that has a factor of 2. Now 2 times 8 gives us 16. Now we've got another prime number here, which is 2 again, and then we continue with 8. So 8 is an even number, so it's got a factor of 2. 2 times 4 gives us 8. So we can circle our 2 again, and then we're left with 4, and you can just write 4 as 2 times 2. So now we have 2 prime numbers at the end, so there's no more numbers that we need to split, so we finished our prime factor tree. So that means that we can write 32 as 2 times 2 times 2 times 2 times 2, as what we just did previously when we did 2 to the power of 5. Yeah. Now, because we have 5 2's, we can write this as 2 to the power of 5, like what we did just the slide before. Okay, so this would be splitting a number into the product of its prime factors. All the numbers that we've circled, all that it's telling us is that if we multiplied all of these numbers together, it would give us our original number. So this kind of leads us on to highest common factors. Now, highest common factor, if you have 2 or more numbers, the highest common factor between the 2 numbers is the largest factor that is shared between them. Now, for small numbers, it's quite simple to find out the highest common factor, because we could just list all of the factors, because there wouldn't be that many. So if we looked at the numbers 8 and 14, so all the factors of 8 would be, you've got 1 times 8, which gives us 8. You've got 2 times 4, which gives you 8. And those are the only factors you have of 8. So you've got 1, 2, 4, and 8 as your factors for 8. Now for 14, you've got 1 times 14, which gives you 14. You've got 2 times 7, which gives you 14. So you've got 1, 2, 7, and 14 as all of your factors for 14. So now we've got all of our factors for 8 and 14. Now all we have to do is find the highest common factor between them. So we need to figure out which ones are shared between the 2 of them. Now in this case, we've got 1, which is shared between the 2 of them, and we've also got 2, which is shared between the 2 of them. There's no other numbers which occur in both 8 and 14. And then we just need to figure out which one is the largest one. So 2 is the largest one, so 2 is the highest common factor. So that's how you work it out for small numbers. You can just list your factors and figure out which one has the largest number. Now, this goes on to lowest common multiple. So since we can find a highest common factor, we can also find a lowest common multiple as well. Now, the lowest common multiple is very similar, just the opposite way round. So we have the smallest multiple that is shared between 2 or more numbers. So when these numbers are small, what we can do is list some of the multiples, the first few multiples of each number, and then pick whichever one is the smallest. So if we think about number 4, if I change back to the black pen as well. So we've got number 4. So what are the multiples of 4? So 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. We've got 16. 20, 24, 28, 32. I would say that's probably enough multiples to write down, enough that you can sort of look between them. If you do, however, write down, let's say, the first 5 multiples of one number and the first 5 multiples of another number, and you don't find one which is common in both, just continue to write some more multiples, and you will eventually find at least one which will be common in both. So let's try the multiples of 7 then. So 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, then we've got to 28, then we've got to 35, then we've got to 42, and they all go on. So already, I can already see a number which is common in both multiples of 4 and multiples of 7. And this number is 28. So since this number is the only number so far that we have found, this must be the smallest number, which is a multiple and common in both the multiples of 4 and 7. So our lowest common multiple is 28. So we've already talked about highest common factors and lowest common multiples when we have small numbers. Now, when we have large numbers, we now need to use prime factors to help us work it out. Because if we have a number larger than 100, it's going to take forever to write down all the factors or however many multiples we have for those numbers. So we need to use prime factors. So we need to start by writing a prime factor tree and then writing each number as products of their primes, and then we'll be able to work out the highest common factor and the lowest common multiple. So let's look at this question here. So find the highest common factor and the lowest common multiple of 24 and 160. So we need to start by writing these numbers as products of their primes. So let's start with the number 24. So the first thing we should think of is 24 an even number? It is. So we know that 2 is a factor, and we can circle it because we know 2 is a prime number. So 2 times 12 gives us 24. Now 12 is an even number as well. 2 times 6 gives us 12, and we can circle our 2. 6 is an even number. We've got 2 times 3. And 3 is a prime number. So we can circle our 3 as well. So we've finished our prime factor tree for 24. And once you finish your prime factor tree, I would say always write down the product of primes underneath your factor tree as well, so you don't forget. So you've got 2 times 2 times 2 times 3. Yeah, so that is 24 as a product of its prime factors. Now, let's do exactly the same thing, but for 160. So we've got 160. 160 is an even number. It is an even number. Now 2 times 80 gives us 160. Now 2 is a prime number. 80 is an even number. So we can split this again using 2. 2 times 40 gives us 80. 2 times 20 gives us 40. 2 times 10 gives us 20. Let me zoom out a little bit. And 2 times 5 gives us 10. And 5 is also a prime number, so we can't split that any further, and we have to circle it. So 160, written as a product of its primes, would be 2 times 2. So we've got 5 2's here. And then we will times it by 5 at the end. So we've done the first part to this question. So we've written both of our numbers as products of its primes. Now we need to use this to work out the highest common factor and the lowest common multiple. So what I would say is write them side by side. So we know that 24 is 2 times 2 times 2 times 3, as what we worked out over here. And we know that 160 is 2 times 2 times 2 times 2 times 2 times 5. Right, so to work out the highest common factor, what we need to do is we need to find prime factors which are common in both 24 and 160 and circle them and then multiply them at the end. So let's go through that then. So in 24, we have a 2, and we also have another 2 in 160. So we can circle these two and write 1, 2 at the bottom. So the important thing to remember is not to write 2 2s. We write 1, 2 because we know that there's a 2 common in both of them. Yeah. So the next one, we know that there's another 2 in 24 and another 2 in 160 that's also common. So we can multiply this 2 with another 1. And then if we look again, there's a final 2 which is common in both of them. So we can write down the last 2 at the bottom. Now there's no more 2s in 24. There's no more 2s that we haven't already circled, even though there are in 160. Now because there's no more 2s, we can't write down any more 2s. And in fact, there's no more numbers which aren't circled, which are common in both of them. So we are finished with the numbers that we need to use to calculate our highest common factor. So all we need to do now is actually do this calculation. So 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. So our highest common factor is 8. Now, to work out the lowest common multiple, we're going to use our highest common factor. So this here is our highest common factor. So to work out the lowest common multiple, what we do is we cross out the numbers that we've already used to work out the highest common factor. So we used all the numbers which we've circled. And then we can write down the highest common factor that we got at the end. Now, we need to go ahead and circle the numbers which we haven't used. So we haven't used a 3, or this 2, or this 2, or this 5. And what we're going to do with them is we're going to multiply it with the highest common factor that we just calculated. So we've got 8 times 3 times 2 times, times 2 times 5. And when we calculate this, so we could do 2 times 5, which is 10, times 2, which would give us 20, times 3, which would give us 60, times 8, which would give us, quick maths, would give us 420. Yeah. So, hopefully this all makes sense. This is the quickest way to work out a highest common factor and lowest common multiple using prime factors. So we can go through a few more examples as well. But before we do, let's quickly go over some quick tricks as well that would be very helpful to figure out which numbers are multiples of other numbers. So we know that multiples of 10s always end in zeros. So multiples of 10 would be 10, 20, 30, 40, 50, and so on. So all of these end in a 0. So all of these are multiples of 10. Now, multiples of 5 always end in 5s or zeros. So we know that they are multiples of 5. So that would be 5, 10, 15, 20, 25, and they go on. Now, all even numbers are multiples of 2, as we've already been discussing through all of these questions. So they will all either end in a 2, 4, 6, 8, or a 0. That's how we know that numbers are even numbers. Now, all the other numbers which don't end in these numbers are called odd numbers. And then the final one, which some of you might know, some of you might not know, the easiest way to figure out whether a number is a multiple of 3 is to add all of its digits up together. And if that number is a multiple of 3, then the entire number is a multiple of 3. So we know the first few numbers for multiples of 3 is 3, 6, 9, 12, 15, and so on. If I continue writing some more, and then I'll show you what I mean when I say add the digits together. So for single digit numbers, these ones here, these numbers we already know are multiples of 3. Now if we look at 12, which is a 2-digit number, if we were to add the digits together, this would give us 3. 3 is obviously a multiple of 3 because all numbers are a multiple of themselves. 15, if we added these 2 digits together, this would give us 6. 6 is a multiple of 3. 18, if we were to add those 2 digits together, 1 plus 8 is 9. 9 is a multiple of 3. And if we did the same thing with 21, we'd realize that it's just going to keep cycling. So anytime you need to figure out whether a number is a multiple of 3, add the digits together and see whether they are a multiple of 3. And you'll be able to tell. So we have a few minutes left that we can go through maybe a few more questions. Let's see. So here we got a past paper question from June 2017. I think this is from the Edexcel paper. And in this question, it's asking you to express 56 as the product of its prime factors. So again, to answer this question, anytime they ask you what is the highest common factor, lowest common multiple, or write a number as its prime factors, then you always have to write down the prime factor trees for that number. So that's exactly what we're going to do in this question here. So let me go back to a black pen quickly. So 56. So is 56 an even number? Yes, it is. So we know that we can write this number as 2 times 28. Now 2 is a prime number. So we've got, so we can circle our 2. And then we can continue with our 28. Now 28 isn't a prime number, so we can continue to split this one. Now 28 is an even number, so we can write it as 2 times 19. Sorry, 14. Going a bit crazy here. 2 times 14. So 2 is a prime number, so we can circle it. And then 14 we can split even further, which is 2 times 7. And 2 is a prime number, and 7 is also a prime number. So we have to circle that one as well. So to write 56 in terms of its prime factors, it would be 2 times 2 times 2 times 7. So all the numbers that we've already circled, we just need to multiply them together, and that will give us the product of its prime factors. Now, one thing that we can also do is we've got 3 2's here. So we're timesing 2 3 times. So going back to what we looked at when we were looking at powers, we know that this is the same as saying 2 to the power of 3. So our final answer would be 2 cubed times 7. And that would be our answer to this question. Now let's look at another question. So a lot of the time, when you are looking at highest common factors and lowest common multiple questions, they're not always very clear. So say for the previous one that we looked at, splitting 56 into its prime factors is very clear, whereas this one isn't so clear as to what topic needs to be used. So here, Tilly the dog barks every 9 seconds. Billy the dog barks every 12 seconds. So they both bark at the same time. So after how many seconds will they next bark at the same time? So this one is actually a lowest common multiples question. Now, these numbers are quite small, so you probably could list all of them, all of their multiples or enough of their multiples, and figure out which one is the smallest one, which is common in both. but you could also do it using your prime factor trees and your prime factors to work it out as well. So for this question, I will show you both ways. I think that would be the most helpful way to show you as well. So if we were to list out all of the multiples of 9, you do 9, 18, 3 times 9 is 27, 36, 45, 54, and so on. And 12, you do 12, 24, 36, 48, 60, and you could continue to go on as well. Now I can already see a number which is common in both. I can already see a multiple which appears in both times tables, which is 36. Now 36 is the first number that is common in both the 9 times table and the 12 times table. So this would be the next time that both of the dogs bark together at the same time. It would be at 36 seconds. Okay, so that would be the way how you do it if you were to list out quite a couple of the multiples for each number. Now, if you were to do it using your prime factor trees, and I zoom out a little bit, you need to write down your prime factors for both numbers. So let's go ahead and do that. So 9, you can only write as either 1 times 9 or 3 times 3. And you can circle your 2 3s. Now, I wouldn't write it as 1 times 9. The reason why is because 1 is not a prime number. So always, when you're doing your prime factor trees, never write 1. That's why when we get to our prime numbers, we have to circle them, because the only other ways that we could write them is 1 times itself. So you never want to find a 1 in your prime factor trees. So we split 9 into its prime factors. So 9 is 3 times 3. And if we do the same thing for 12, 12 is an even number, so we could do 2 times 6 to get to 12, circle our 2. 6, we can write as 2 times 3, and 2 and 3 are both prime numbers, so 12 we can write as 2 times 2 times 3. Now, for this question, we want to work out the lowest common multiple. Now, remember, when we're working out the lowest common multiple, we want to, first of all, work out the highest common factor and use the highest common factor to work out the lowest common multiple. So if we write it how we was written in the previous questions, so 9 is 3 times 3, and 12 is 2 times 2 times 3. So the highest common factor for 9 and 12 would be 3, because 3 is the only prime factor which occurs in both 9 and 12. There's no other numbers which we haven't already circled here which appear in both 9 and 12. So here our highest common factor is 3, and we're going to use this to work out our lowest common multiple. So we've used this 3 and we've used this 3. So the leftover ones is this 3, this 2, and this 2. So we're going to multiply our highest common factor with the leftover numbers. So 2 times 2 times 3. And this will give us 3 times 2 is 6, times 2 is 12, times 3 is 36. So our lowest common multiple would be 36, and when we zoom out a little bit, we realize that that's already the number that we worked out. So we will always get exactly the same answer no matter which way that you do it, as long as you do it correctly. Okay, so we probably have time for maybe another question, one more question before we have 15 minutes to go through the other questions. So let's go through this one then. So a lot of the time, you do sort of get these sort of questions on a GCSE paper. And it's usually split into parts just like this. So we've got 84, and we want to split it into its prime factors. So again, we split it into a prime factor tree. So 84 is an even number, so we've got 2 times 42 would give us 84. We can circle 2. 42 is an even number, so we can split this as well. So we've got 2 times 21. 2 is a prime number, so we can circle that one. And then 21 isn't an even number, but it is it's not a prime number. So we can write it as a product of 2 other numbers, which are 1 and 21. And those 2 numbers are 3 and 7. 21 is a multiple of 3 and 7. Now 3 and 7 are both prime numbers. So we can circle those 2 and we're done. That's our prime factor tree finished. So we know that 84 can be written as 2 times 2 times 3 times 7. Now, because we have 2 2's here, we can also write this as 2 squared. So we've got 2 squared times 3 times 7. That would be our answer to question 8, part A. So now we're going to use part A to work out part B. So this one is asking us to find the highest common factor between 84 and 35. Now we've already split 84 into a product of its prime factors. So all we have left to do is to split 35 into a product of its prime factors and then work out the highest common factor from there. So let's split 35 first. So 35 is not an even number, but it is a multiple of 5 because it ends in the number 5. So 5 times 7 gives us 35. Now 5 is a prime number and 7 is a prime number. So that's the only way that we can split 35 into a product of its prime factors. So 35 is just 5 times 7. So to work out the highest common factors, as we've done previously, let's just list the prime factors that we already have. So we know that 84 is equal to 2 times 2 times 3 times 7, and 35 is equal to 5 times 7. Now, there is only one prime factor which is common in both of these numbers, and that number is 7. So 7 is our highest common factor. There's no other numbers which we haven't circled which are common in both 84 and 35. So our answer to this question would just be 7. And that is highest common factors and lowest common multiples.
Great, thank you so much, Evelyn. I have had some questions come through, so I'll read some of the ones that I've seen. If you have any more questions, then please ask them, everybody. So we had a question asking, what if you had 2 prime numbers to begin with, but they are too large to spot? How can you tell if a very large number is a prime number, such as 2 times 2 times 2 times 7?
Okay, so for your GCSE foundation exam, they're very unlikely to ask you a question which has a very, very large prime number. If they ask you to split a number into a product of its prime factors, it will always be a number which is not a prime number. So they'll never ask you to split a prime number into prime factors. That won't ever be a question. I think the highest number that they will expect you to know is a prime number is 29, so the 10th prime number. So you should know all your prime numbers up to the 10th one, which is 29. Does that answer the question?
Yeah, I think so. We had another question that asks, for the lowest common multiple question, if it's 24 and 160, isn't the answer 480, not 420?
Yes, you're probably right. I'm sure yeah, you are absolutely right. 60 times 8 is, yep, that should be 80. Yeah, sorry about that. You're absolutely right. Is there another question as well?
I think that was most of the questions, and in that case I think we probably have a few more minutes to run through some more of the content.
Yeah, okay, perfect. So we reached question 8. So I do have a few more, and I do have some extra questions as well. So this particular question was from the November 2018 paper 3 question, and looking at some of the examiner reports, quite a lot of people didn't actually spot that it was a common multiples question. So let's read through the question. So we've got Bert has 100 cards. There's a whole number from 1 to 100 on each card. No cards have the same number. Now Bert puts a star on every card that has a multiple of 3 on it. So he puts a circle on every card which has a multiple of 5 on it. So work out how many cards have both a star and a circle on them. So for this one, we know that every single multiple of 3 between 1 and 100 has a star on the card. And every card which has a multiple of 5 between 1 and 100 has a circle on it. So the way how I would say to do this question, and the easiest way, which will probably confuse, which would probably be the least confusing, is to list your multiples of 5 and see how many of your multiples of 5 are actually multiples of 3 as well, because we just want to find the numbers which are multiples of 3 and multiples of 5. So you could do it either way as well. You could list all your multiples of 3 and see how many are multiples of 5 between 1 and 100. The only reason why I'm saying multiples of 5 first is because you'll have less multiples because it's a larger number. So let's start with multiples of 5. So they're quite simple to list because you've got 5, 10, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, and 100. So we've got all our multiples of 5 from 1 to 100, any numbers which are within 1 to 100. So the next thing that we need to do is probably the best thing is to circle all of your multiples of 5, which are also multiples of 3. So if we go back to the tricks that I was going through earlier, to work out a multiple of 3, you could just add the digits and see whether that number is a multiple of 3. So 5 isn't a multiple of 3, so we're not going to circle that one. 10 is also not a multiple of 3, but 15 is a multiple of 3. And to check it, we could do 1 plus 5, which is 6, and we know 6 is a multiple of 3 because 3 times 2 gives us 6. Now 20 isn't a multiple of 3, sorry. 25 is also not a multiple of 3, but 30 is. 35 is not, 40 is not, 45. If you add 4 and 5, it gives us 9. So 45 is, 50 is not, 55 is not, 60 is, because 6 plus 0 is 6. 65 is not, 70 is not, 75 is, because if you do 7 plus 5, you've got 12. 80 is not, 85 is not, 90 is, and those are all the multiples of 5, which are also multiples of 3. So the actual question was asking us to work out how many cards have both a star and a circle on them. So how many cards are multiples of 5 and multiples of 3? So we've circled 6 numbers here. So 6 would be our answer, because that's how many cards would have a circle and a star on them. Let's go on to the next question. Hopefully that makes sense to everyone. The next question is similar to the one that we did previously to that. So we need to express 120 as its prime factors, and then afterwards we need to work out the lowest common multiple. So 120 as a product of its prime factors, we need to write down the prime factor tree. So 120. So 120 is an even number. We've got 2 times 60, so we can circle the 2. 60 is also an even number, so we've got 2 times 30, circle the 2. 30 is an even number, we've got 2 times 15. 15 is not an even number, but we still can split it into 3 and 5. So we can continue with this. So we know that we've got all our prime factors now. So we know that 120 is the same as 2 times 2 times 2 times 3 times 5. Now we've got 3 2's here, so we can also write it as 2 to the power of 3. So our final answer would be 2 cubed times 3 times 5. So that is 120 as a product of its prime factors. Now, one thing that I'd like to particularly point out with this question as well is that it says product of powers. So all the previous questions, we've been writing it this way anyways, which is a good thing, because I would suggest you to do it like this all the time. But for some questions, they might particularly point out that you have to write your numbers as powers. So in this case, you would have had to have written 2 to the power of 3 in your answer. You couldn't have written 2 times 2 times 2, otherwise you wouldn't get the final mark. So be careful when you are answering these questions, and be careful to read how you're supposed to represent your answer. So we've got our product of prime factors for 120. So our next one is to work out the lowest common multiple between 120 and 150. So we've already written 120 as product of its primes. So let's do 150. So 150 is an even number. It's 2 times 75. And circle the 2. Now 75 is not an even number, however it is a multiple of 5. And we've got 5 times 15 would give us 75, and we circle the 5. And here we have 3 times 5 for 15, like what we did previously. So 150 written as a product of its primes would be 2 times 3 times 5 times 5. Now we have 2 5's here. So if you were to answer this question as a product of its primes, you would write down 2 times 3 times 5 squared. But because we don't need to write down the actual answer to this, we don't need to write it down as 2 times 3 times 5 squared at the moment. All we need to know is what the actual prime numbers are. So we know 120, if I zoom out a little bit as well, so we can see everything. So 120 was 2 times 2 times 2 times 3 times 5. And 150 was 2 times 3 times 5 times 5. Now we just need to find prime factors which are common in both numbers. So we've got a 2 in 120 and a 2 in 150. So we can write 1, 2 at the bottom. Now there's no more 2's left over in 150, but there are 3's which are common in 120 and 150. So we can multiply this 2 with 3, and there is a 5 as well. So we can multiply this by 5. So there's no more numbers which we haven't circled, which appear in both numbers. So this is our highest common factor. So 2 times 3 is 6, times 5 is 30. So this is our highest common factor. Now the question is asking for us to find the lowest common multiple. So we're going to use our highest common factor to work out the lowest common multiple. So the numbers that we've used for our highest common factor, we can cross them off and write down our highest common factor at the bottom, and circle the numbers which we haven't already used, so the leftover numbers, and multiply this with our highest common factor. So we've got 30 times 2 times 2 times 5. So 2 times 5 is 10, times 2 is 20, times 30 is 600. So 600 would be our lowest common multiple. And we probably have maybe time for another question. So let me just get one of those up. Let's do this one. So this is sort of another like difficult question where it's kind of hard to see what needs to be done. But let's read through the question and we'll see what we have to do. So trains at Portadown leave a train station every 28 minutes, and trains to Portrush leave a train station every 16 minutes. So a train to Portadown and a train to Portrush both leave the train station at 8 a.m. So when will a train to Portadown and a train to Portrush both leave the train station at the same time? So again, anytime you have a question which tells you that something happens every so and so seconds or so and so minutes, and the same thing for another event or another object, then you know that it has to be a lowest common multiples question. So we want to find the lowest common multiple between 28 and 16, find out how many minutes later they'll both leave at the same time, and then we're going to add it on to the 8 a.m. to work out how many minutes later after 8 a.m. it will be. So because these numbers are quite large, I would say use your prime factor trees. So you've got 16, which you can split up. So 2 times 8, 2 times 4, and 2 times 2. So you've got all of your prime numbers here. And the same thing for 28. So you've got 2 times 14, 2 times 7. So you've got 2 times 2 times 2 times 2 for 16, and 2 times 2 times 7 for 28. So to work out the highest common factor, you need to circle the numbers which are common in both. So here we have a 2 which is common in both. So we've got these 2 2's. So we write 1 2 at the bottom. We've also got another 2 2's, and then after that there's no other numbers which we can use. So 2 times 2 is 4. So that is our highest common factor. Now, for this question, we want to work out the lowest common multiple because we want to see when is the next time that they're going to leave at the same time. So we've worked out the highest common factor, so we're going to use this to work out what the lowest common multiple is going to be. So we've used these 2's already for our highest common factor, which is 4, and our leftover numbers is 2, 2, and 7. So we can multiply these together. So when we work this one out, we will get to, so 4 times 7 is 28, times 2, which is 56, times 2, which is 112. So 112 minutes later, the trains will both leave the train station at the same time. Now we haven't finished the question yet. This would only get you 2 marks. The reason why is because we need to work out what time will it be. So we know that we started at 8 a.m. and we need to add 112 minutes onto the end of this. So 112 minutes is the same as saying we should split this really into hours and minutes as well because it will make it easier. So we know there's 60 minutes in an hour. So if we split it into an hour and minutes, this would be 1 hour, and then we're left over with 52 minutes because this is 60 plus 52 would give us 112. So when we add, if we add an hour and 52 minutes onto from 8 o'clock in the morning, we would be left with 9:52 a.m. That would be the time that both of them would leave the station, an hour and 52 minutes after 8 a.m. And this is probably one of the hardest questions that you would get in relation to highest common factor and lowest common multiples.
Great. That was really, really good. Thank you so much, Evelyn. Thanks to everyone for sticking around. That's all that we have time today for Maths Foundation level. But if you've signed up to the My Tutor online school, then you'll be kept updated to as and when we have more sessions for you on this level. Just to say also, lots of you were asking about English and are wondering when that will start. So we don't have an English session today, unfortunately, but we should have one tomorrow. We were meant to have one today, and due to sort of unforeseen circumstances, we can't have that anymore, but stay tuned for information about the one tomorrow. Thanks everyone, and thanks Evelyn, and hopefully see you guys soon for some more sessions later on today. Bye.